Question 7. Determine the derivative from first principles if f at x is equals to negative 4x squared. Okay. This is the formula that we use when we are dealing with first principles. You don't have to memorize this formula, by the way. It will be given. Here it is, right here. So f at x is equals to negative 4x squared. And then f of x plus h should be equals to negative 4 into x plus h squared. Negative 4, this is x squared plus 2xh plus h squared. Negative 4x squared minus 8x h minus 4h squared. Now let's substitute. Limit as h approaches 0, f at x plus h is equal to negative 4x squared minus 8xh minus 4h squared minus f at x, which is negative 4x squared all over h. Limit as h approaches 0, so that this is going to be positive. Negative and negative will give a positive, so the 4 will cancel that 4. You'll be left with negative 8xh minus 4h squared all over h. So limit as h approaches 0, we are going to take out a common factor of h. So we'll be left with negative 8x minus 4h over h. So that when you multiply with the h, you're going to get back to minus 8xh, and then you'll get minus 4h squared. So the h will take care of the h. Limit as h approaches 0, minus 8x minus 4h. So minus 8x minus 4, then the h must be 0. So you'll be left with negative 8x. And you can check if your answer is correct. You'll just take this minus 4x squared, and then you find the derivative. So this is minus 8x, which is the same as that one. So yes, your work is definitely correct. So they want us to find f prime. F prime should be equals to 6x squared minus 3. Plus 2x squared minus 5. So let's just fix this. So this is going to be x 2 over 3 plus 2x minus 5. 2 over 3 x, and then 2 over 3 minus 1, that's minus 1 over 3, plus 2 into negative 5x minus 6. So here I'm getting 14 over 3 x to exponent of 1 over 3 minus 10 all over x to exponent of 6. Oh. 7.3. For which values of x will the tangent to f at x have a positive gradient? So we are given f at x, which is that we know that the general formula for a cubic function is given by is equals to ax cubed plus bx squared plus cx plus d. So the coefficient that is attached to x cubed is a. So when the value of a is less than 0, in this case a is negative 2, we are going to have a DID function, so it's decreasing, increasing, and decreasing again. And when the value of a is greater than 0, we are going to have that function. So in this instance, we expect our graph to fit this scenario. For which values of x will the tangent to have a positive gradient? So at the turning point, we know that the gradient is equals to 0. And if we were to draw a tangent at this point, you can see that the gradient is negative. Even anywhere along this, the gradient is negative. So the values that they are looking for will be at this turning point and that turning point, and in between here. Because if we were to draw a tangent here, the gradient will be positive. So we need to find the coordinates of the turning point. And we know that the gradient at the turning point is equals to 0. So 0 should be equals to negative 6x squared plus 8. So I'm getting 4 over 3. So x should be equals to plus minus 2 over square root of 3. So our function looks like that, where this side is negative 2 over square root 3, and this side is 2 over square root 3. So the gradient is positive. Here the gradient is 0, and at the other turning point the gradient is 0 as well. But if we were to draw a tangent here, the gradient will be positive until just before the turning points. So the x value, it should lie between 2 over square root 3 or minus 2 over square root 3. I'm not including the values. It lies between them, but it does not include them because the gradient at the turning point is 0 there.